All right, the third class of problems that you guys asked me to post examples of is investigating a graph and discovering what function that graph might be of. There are two lines here. I've labeled them because this is a black and white printout so you can't see, but in the PDF I sent you, this one here is blue and this one here is red. The blue one is sort of easy to discover the function by investigating where the roots of that polynomial are. These both look roughly polynomial. They both look like the highest order of that polynomial is odd because they come off the bottom of the page and end off the top. If it was even, we'd expect it either to come down from the top and then back up, or come up from the bottom and then back down. So here we have the roots of the equation. So it crosses the x-axis at -3, at -1, and again at 2. So I've gotten myself a little bit of start. So I wrote down that we've got 3 points that we're interested in. There's -3, 0, -1, 0, and 2, 0. Now we know at each of these points where x equals -3, x equals -1, and x equals 2, y is going to equal 0. How can y equal 0? If one of these terms is 0, because we're multiplying everything together. So we can just write down x and then add and subtract something such that when x equals that, this term goes to 0. Well, what can I add to -3 to get 0? I'm going to add 3. Now I'm looking at this point. What can I add to -1 to get 0? I can add 1. What can I add to 2 to get 0? Well, I can add a -2, or I could subtract 2. And then what I'm going to do is just multiply these things out. So y is equal to a, and I'm multiplying these two terms here. So just multiplying a binomial, we have x squared plus x plus 3 more x's is 4x, plus 1 times 3 is 3, times x minus 2, just copying that term down, and then we'll just do that again. A times, we'll take all of these terms times x, and then all of those terms times -2. X squared times x is x to the third. 4x plus x is 4x squared. 3 times x is 3x. -2 times x squared is -2x squared. -2 times 4x is -8x. 3 times -2 is -6. All right. Now I'm just going to combine like terms. Y equals 8 times quantity. There's no other x to the third term. We've got 4x squareds minus 2x squareds. So that's plus 2x squareds. We've got 3x's minus 8x's. That is minus 5x. And then we have only one term that's just a constant. So -6. So we're not quite done. This is a perfectly good polynomial, but we're multiplying it by some constant a. And if I look on my sheet, I can find another point along this blue line that might be easy to figure out. And how about this one right here, where x is 0, y equals 3. So I'm just going to write down that point in this list. We're going to add the point 0, 3 to the points that are of interest to us. And then we'll just write it down. Y equals 3. So 3 equals a times, and x is 0. So 0 cubed plus 2 zeros squared minus 5 zeros, all of that is 0. And we get, oh, and I messed up slightly. This is clearly minus 3 and not 3. So I'm going to add a minus sign right here and a minus sign right there. So everything inside the parentheses just simplifies down to just negative 6. Well, divide both sides by negative 6, and we end up with 1/2 equals a. So just to kind of get our formula into a canonical form, we're going to do y equals, and we'll just multiply through by a half, 1/2 x cubed plus 2x squared times a half is just x squared, minus 5x times a half is minus 5/2 x, minus 6 times a half is minus 3, and there you have it. So if you were to stick that function into a graphing calculator, you'd end up with something similar to the blue line. So